So, what can we figure out today? That's a good question. And I do not know the answer. What I've tried doing here is adding light. Now, you need to do something here. Here we have to say if T out is greater than. And we're not going to do this. Here we just want a hit. So if we get any hit at all here, well, it's a little bit so I feel like I need a boolean or something in here, but I don't like that either, because that just means more things I have to pass around. Like maybe saying float team in here is okay. No, it's not. Then here we have to do this, and we should not continue. We should say if t min Nah. It needs... I had a thought, but it disappeared. It should be like this. I think this might kind of be what's missing, but it's still behaving extremely strangely, so I'm not sure. I don't know. Let's just try it, I guess. No, this should be here. And I don't understand. It's so buggy. Like, why is it doing this? Why is it hitting the sides so like that? It's so strange. There too. Just don't really get it. Basically, I am trying to cast shadows right now. The rest isn't really finished, but I just wanted to try to implement it because it helps me tell the shape of the world, right? And it's a little hard to tell otherwise. But it's just being a bitch, and I don't really get it. It's like here, if try hit is true, that means we've hit a triangle. And I am doing backface culling. I am. So when I hit something, we then iterate the ray to the point of intersection by taking ray direction times t-min. T-min is the distance that we got out of this. And that should work. And that might be okay, but what I think is potentially happening here then let's try that, see what that says. Because t-min cannot be 0. for the light ray, because that means an intersection with itself. Doing that doesn't help either. And I thought that, hey, maybe subtracting like 0.99 from the ray would help, because that would put us right in front, not on top. So that way, when we change the direction of the ray, we're gonna get the correct thing. Like, it's gonna either move away or it's going to intersect with itself, which it should. But here now, what would happen, I think... Well, no, it would intersect with itself anyway, but it should be able to both intersect with itself and move away, because it's if it moves away, then the cross product and dot product stuff should be negative. So it shouldn't, like, that's where backface culling should come in and nothing should happen. But it's doing this. I don't understand what's happening. And it's doubly difficult because I don't actually have cube shapes. So I don't know what's causing the rendering issue. Like, why is it doing this? Like, it doesn't make any sense. So weird. I don't know why, but like ray magnitudes and directions, I feel like they are just wrong. Like, a lot of the time they're just straight up wrong. Like, what shouldn't this should work? Team in. Ray direction plus team in. That's the normalized ray direction times the distance traveled to intersect with the triangle. And I have to do that, because we have to bounce the ray from the point of intersection. And then I have to make an immediate triangle check to see if we intersect. But I shouldn't, I actually don't think I should have to do anything different. I thought I did, but I think I don't. But even so, this is not working. We can do this. Try hit equals -1. Change this to if try hit greater than or equal to 0. And we do that, break. It's so strange. So the sun is up there. No. Yes. Yeah. The sun is there in the corner. So as you can see, it's like it's kind of right in some manner. Like, what is this? What is this? It's so strange. And see, it's like it's behaving in some. Because down here, this kind of behaves correctly, right? Like, actually not entirely. But these squares also are, like, kind of get in the way. So I'm not really entirely sure. But you can see, I do think this kind of works properly. Up until we go... No, okay, it does work all the way. But then here, it's like the coordinates are like reversed or some shit. That's not possible. The ray direction isn't like, it's normalized, but it's not absed in any way. I'm taking the sun position minus the current position. That's the new direction. Right? So what is the issue? I don't get it. I recalculate the ray, I recalculate the delta dist, I recalculate the side dist, the position, everything that's necessary. And that's not a whole lot. And then we just pass through like a million miles of commented code here. Find this, which is useless. And then we end up down here. This is where we iterate. That's why I have to check immediately, because once this is done, we then iterate the map position. And then we do all of this nonsense, which doesn't have anything to do with anything. Wait, what? There, right. And here we set the result. There's just nothing that could matter here. I think I tried this already. I don't think it makes a difference. Because when you look at it, you're like, okay, there's something wrong with this. The fact that we are doing sides, but I don't know. It's just like not properly intersecting with itself. Yeah, no difference. Because you can see it, it's like we have an internal shadow. It's like there's a shadow inside of it. Well, I think the whole thing should be in shadow. Potentially. I'm not sure if that's true. I feel like I'm just doing something really wrong. Here we got a nice triangle, so that's good. That's good. Does that mean anything? Does 0.5 mean anything? Gives us a nice triangle? I want to point out that this one does not get shadow, because these don't cast. So somehow what's happening it's kind of square here. Somehow it's like, I mean, I feel like it's not intersecting with itself. Maybe. But that's what's weird, because if this was 1, this is like default behavior. The reason I added this multiplier here, right, is so that I could multiply the ray out, like, just a little bit. So that way, if it ray traces into itself, it's going to find the triangle again, like guaranteed, instead of it just being like, it's at 1 or like point, you know, negative 0.9999 or negative 0.000001. Or some bullshit like that. But it's not... It's like not doing that. It's not doing what I'm asking it to do. That's why I'm so confused. Because I feel like this, like the ray position that I multiply in, that should work. It should put us at the position of this. We can try doing maybe this, or I think that should disable slopes. And if we start there, that might help, because right now we have two simultaneous things going on that might make it harder to troubleshoot. Got the slopes and we've got, and you can see here this works perfectly. This is how it should work. Right? So there's nothing like inherently wrong there. It's like the second I introduce the sloped triangle, it breaks. What happens if we do this? No, that's fine, right? Like, it's all good. That's how it should work. Here it is correct. It's completely correct. What's happening there? Here we have some strange behavior. Well, maybe it's not that strange. It's because the Y is so low that it's casting shadows through the world. The sun needs to be that high, otherwise, yeah, that's what's gonna happen, right? Yeah, I don't see any problems. That's... here, this is kind of odd, but I think this is an artifact of the fact that when you look at it from this point of view, there are so many, like it's missing because of this here. Oh, yeah, I was a little bit out of it for a few days. It was not very relaxing, but I had to take a few days off. These shadows are not playing along. I don't understand why. Ah. Maybe... Need to do this. I doubt that is... I doubt that is it. I doubt it. I'm a doubter. Yeah, no. This, what is happening here, right? Like, I feel like no matter what, especially if we lower this, like now, if we have like 2 lengths here, this slope should be in shadow. Like that only makes sense to me. And you can see, like, it doesn't really matter. And it's almost cube shaped here, so I don't get it. Why is it not working? So strange. Like, the position is just wrong. Now, the sun is below the world. And even then... Like, is my ray calculation wrong? Like, what is happening? It's like it's going off in another direction or something. Doesn't really make sense, does it? This could almost make sense if all of these were finding like this cube. Why is it here? If try count and isn't light ray, then we just do this. What if we don't break here? Let's do this. If try count does not equal 0, then we're gonna set the voxel config to 1. That's gonna give us cubes. That should at least eliminate the pink squares from the problem. Though they're not. We have to do that. Because if the try count is 0, that means that we have entered a voxel that has volume and content, but we I don't have a valid triangle configuration for it. Oh. That's an accident, but it might actually be useful here. Not entirely, actually. It doesn't... It does confirm that it's not, like, intersecting with that. It's just wrong. Like, it's just not working. That's the only thing that works. Why is it broken? Ah, there it is. Found it. I think we found it. Here. I'm using the entry UV to do the triangle check, but it should be the current ray position. Let's try now. Though, the current ray position probably doesn't work. It needs to be translated into a UV, I think. How do we do that? Entry UV. I'm not sure I need to do these things here, but maybe, I'm not sure. No. I don't think I do. Let's grab this. And then we need to go down here. And we need to say current UV or some shit. And we don't need to do this mask stuff, I think, because that's for setting it to a min or max, depending on what's going on there. So that should be good. And then this should be current UV here. Let's see how that works. This looks good, actually. Fuck me. Ugh. Now we are having some issues with the inverse. Why is it inverted? Why does this not affect it? Why is it inverted? Why is it black? Oh? It's like a division by 0, because it runs like shit when you look at it. All right, let's look at this. So if we are currently at like 2 2 2 2 3 1, and the sun is at 0 10 0. Then we're doing sun minus position. And that's -2, 7. No, it's 2, 7, 1. No, it is -2. -2, 7, -1. That's fine. That's correct. So confused. I feel like it's probably just some BS. Current UV, ray direction. This is so strange. Because the sun position actually doesn't even affect that problem. I feel like this and this is the same problem. So if we can solve this, this should be solved. And here it makes a little bit more sense since it's just square, but... the hell? Because I enter here, and then I should find this here. Then why is this... because it should land on the pixel here on top of this voxel, and then it should shoot a ray up. So why is this part of it shooting a ray down and intersecting with because here, t is set to -1, right? And here, this should return false. And t isn't set until down here. So here, if t is greater than t max, return false. But it shouldn't really matter because here, t should... like even if t gets set to something higher, it shouldn't matter Because it's return to false, and it just shouldn't matter. But it could simply be something like that. Like I'm actually just letting something through, even though the math is correct. I think so. Where's this coming from? Is the cube incorrectly implemented? Zero, 3, 1. 3, 2, 1. And 1 is -1, 1, -1. 2, 1, 1, -1. 3, 1, -1, -1. Yeah. So what about bottom? 3, 0, 7. Let's say this says 0. 3, 0, 7. Yeah, it should be correct. Three, 0, 7, 0, 4, 7. Yeah. One, 2, 5. 2, 6, 5. I wonder... I wonder if I'm running into some kind of register issue. I kind of don't think so. I think that's just gonna slow it down. I don't think it's gonna yield incorrect results. Oh, actually, I made it even darker. I was going to make it less dark. But yeah, like... so strange. The only thing that makes sense here is that my new ray assignment isn't doing anything. That's the only thing that makes any sense here, because as I hit this wall, what's supposed to happen is that in this particular scenario, we are supposed to intersect with this wall here, and this should set t to 0, because we intersect immediately upon entering the voxel. And I then increment the ray to the intersection, which in this case is 0, and I then turn the ray towards the sun. And then I do another intersection check immediately to see if that intersects. But it's intersecting with the bottom of itself? And then it iterates, like, down? Because it perfectly lines up with the original ray direction. Do we try this again? Wait, hold on. This is wrong. I didn't finish updating this. I just grabbed it and deleted this. So this is actually unaltered. This should look like this. I went to fetch that because I was using the global ray position instead of the UV for the voxel internals, and then I didn't actually set it. So we've been operating on the same bug the whole time there. So let's see if that does anything. Well, it sure didn't really help. It's behaving differently. Everything feels bugged as hell. Even the colors feel wrong. Like, you can see over there, you can see some bright pixels. And over there, like, it's behaving extremely oddly. This doesn't help. Okay. Dividing it by half kind of works. Why? I mean, you can see it's got a bunch of errors there still. But this actually kind of works. But it kind of makes sense in a way on these, because these are divided by 2, if that makes sense, right? So I feel like we're not getting a true T. Just look here. The T-min, if this is a hit, then T-out, if hit and T-out is greater than 0, greater than or equal to 0, and T out is less than T min, then T min equals T out, right? And if try hit is greater than -1, then there is a T out, or there is a T min. If there is no T min, there is no try hit. So we have one here. So hello, Rapier. All right, dude. Good luck at work. Don't smash any thumbs. So see, here's the issue. Here, we've got that. And the current ray position What is the issue? Entry ray position. Its last ray position. Is this wrong? I don't think this is wrong. Because everything here is based on this, and this works, and has always worked. So I have no reason to suspect that this is broken. And here we have entry ray position equals temp ray position. And this is what I'm using, the entry ray position. I don't know why. I feel like this is wrong. Somehow. But it shouldn't be. No, it should be right. Because what I'm doing here, this is a little tricky, but basically, you can I think you can kind of see it as you have 3 rays. And each axis is a ray. Like X is a ray, Y is a ray, and Z is a ray. And the way it works is that we have 2 values here. One is called a delta dist and one is called a side dist. So the delta dist is... This is gonna be complete gobbledygook, but the delta dist is how far it takes before X has traveled a full cell. So basically that means that the more vertical the ray is, the less often it's going to traverse in X. And that means that the delta dist for X is going to be higher. And every time we traverse a voxel, what we do is we increment the side dist of each axis, that, or the axis that is currently traversing. And we do that by adding the delta dist value for that axis to itself. And what that kind of translates to is that the delta dist is the distance traveled, right? And therefore, if you take the side dist and you subtract the delta dist from the entire vector, and you then multiply it by the mask for our last step, that results in getting the magnitude of the ray to the last position before the last step. And what that means is that if we're traveling from the left, or from the right, that should give us because this is where my brain kind of doesn't compute. Because when we're traveling, we're actually traveling to like the left, to the bottom left in a way. So, or I think so at least. I mean, not really. How does this work? If we start here, we then calculate the side dist for our target destination, right? This is where we want to go. So here we can then tell, okay, we need to go to the right first. And in order to move to over here, what happens is that we increment the side dist by the delta dist. Yeah. So first, on the first step here, we just calculate where this is, and then that's it. And then on the next step, we then increment the full value, we move over here, and then it's incremented to here. And therefore, because this is immediately incremented to over here, that means that in order to get the entry position, we have to subtract the last delta dist that was added, and then we get the highest side dist value. Is this correct? I think it is, because it works perfectly, other than this bullshit here, so I have no real reason to suspect that my ray is broken. in any real manner. But like here, for example, adding that would subtract it to here. But the reason I'm like suspect is because it's not really accurate. Because let's say there's a block here. That means we intersected here, right? And this is a y step. So if I then subtract from y, then we'll end up with this. This is the intersection here, or here, something. And then down here, we've got here. So if I subtract this distance, no, actually, because it's like this. It's this distance that I'm subtracting. This is the one that was incremented, so it's always to the last step. Because we stepped in here, added like a huge value, and then I subtract it and we end up back here again. So yeah, it is correct. There's nothing wrong with this approach, except that I have to do length, which sucks. But I'm scared of adding a value repeatedly to one variable, because it's gonna eat up like so many registers, I think, if it works how I think it works. Because then like having a register that's live from here, the beginning of the loop, to the end of the loop that just tracks the current length, I think would suck ass. And that's why I'm just extracting it from the side dist. Because the side dist is that's what the side dist is. It is the distance. And so it's like, what's better, doing the length operation or actually just storing it? I'm not sure. But I have a significant register usage issue, and that's, I think, because I'm doing all of this shit here. Like, every time I do something, every time the array moves from voxel space to brick space to wall space, and then back down again, it recalculates the ray for every step every time. And every time it recalculates the ray, that means we are adding a new value to current ray position, last ray position, wall map position, wall side distance, wall, old wall, etc, etc, etc. And even just this storing old wall and setting a new wall, I think this is also bad. Because here, right, I'm setting wall down here. Well, I think wall should be set here in the for loop. So every single time that the loop iterates, it should release the register. And the old, I think I just either need to I shouldn't need to do that at all, actually. Well, it's a little tricky, right? Because it's like what I'm doing is I'm fetch. Well, I guess it doesn't matter because I'm doing it anyway. Like I'm fetching the voxel, and then I'm checking if the voxel's wall is the same as the last one. And if it's not, then we do something. Because otherwise I have to check. If we're stepping in voxel space, I then have to check the wall every step. But maybe that's just better. Like, it feels like waste to do that, but because that's a load. And I don't want to have to do like 3 loads every single step. But I think if I don't, then it's gonna eat up a lot of register usage, because every single variable that is reassigned in this for loop and is assigned outside of the for loop, every time you assign to it, it's not like getting overwritten, it's getting like it's getting like duplicated, from what I understand. I don't know exactly if that's how it works, but that's how I've understood it. So it's like a value is getting added on top, and we're now reading that instead. And next time we assign it, it gets added on top of that. Now we're reading that on top, reading that on top, reading that. And it doesn't release all of these before until it falls out of scope. And that's why, as much as you can, you should assign things in the for loop, I think. Or not assign, declare them in the for loop. That way, every loop, they should be released and reassigned to whatever they need to be. But usually when you're looping, you need values to iterate. So you not I don't always do that. But this is the segue. That's not what we're fighting here. Right now, I'm still trying to figure out what is going on with this bullshit. Actually, nah. And here, for example, this here, this is gonna eat up, I don't know how many registries. This is probably like 50 registries in and of its own. But that's okay, because it's in this local scope, which should then fall out of scope. At least in theory. But it's not that simple either, because this here, I ran a profiling program on it, and basically, from what I understand, there's like a limit of 255 live registers, and more or less, like each variable uses up a register. And here we have all of these loaded voxel data structs, right? And they contain a float and a float 3. So that should be 4 registers per loaded voxel data that's assigned here. And that's like 100 on its own. No, it's like 200 on its own, almost. I think. No, it's 100. Because this is like 27 times 4. Assuming that's accurate. But commenting all of these out didn't actually change the live register usage in the profiler. So I don't know. But there's two. It says live registers and it says registers. And I think that live registers are like globals. So they're just kept alive. And these are local. And it also has like a register count that just says 255. I don't know if it just says that or if it's because I'm vastly exceeding the register limit. Which works, by the way. It just slows down everything. Like you really want to keep it at like below, but I'll worry about that later. I did change some things here to fix my register bottlenecks a bit. Like I reduced it by like 3 live registers and I gained like 200 FPS or something. At first I thought it was 500, but that's just because when I changed that, it like fixed a bug. That was the bug was making it work correctly, but it was bugged, so fixing it made it not work. And then I had to make it work properly without the bug. And then instead of gaining 500, I only gained like 100 to 200 FPS, but it was still a lot. But it doesn't seem to me that registers will make me get like incorrect behavior. So I'm still kind of confused at what's going on here. Like the current ray position here is a global, so that might be a problem. So maybe we just change the value of some of these. Last ray position, I don't know if any of this shit matters. Strongly doubt this is gonna do anything. I don't know. I don't feel like it's. I don't know. It's really hard to tell a lot of the time whether it's working properly. Like, is it my bug or is it there like an HLSL? Like, it's not an HLSL bug, but rather like it's not my logic or my code that's really the issue. It's there's a limitation in the HLSL and like just in graphics programming in general that's making it do some bullshit. And now, like, why is it? See what I mean? Like, I don't know. Now, like, I want to point out that we no longer have the issue of like this, it being inverted, and I don't know why. And it actually works now, though not really, because these values are all just some fucking bullshit. And it's kind of like, what this kind of tells me, in some weird way, is that the t that it's being that's being returned here is actually like maximum. That's kind of what this means for me, because otherwise this changing this wouldn't do anything. So it's like I enter the voxel, then we intersect the triangle correctly, by the way, and then we're supposed to return a t. But the t is like not the value I'm expecting here, even though it should be. A t should be a value from 0 to I don't know what the value is. It's like 1.34 or something, whatever. It's the maximum magnitude. Of 1. This value here, 1.414. So that's what it should be returning. Like if I'm looking at it from up here, and then the ray enters here, shoots through here, and then intersects here. What I feel that is happening is that it's just like shooting through here, and then it's just getting me this value. And then when I subtract, or when I multiply this by 0.5, it's just kind of putting it here. Like, not correctly, but it's just kind of what it's doing. And I don't know if that's the case. Now, I think it might actually need to be subtracted by 2. And the reason for that is because here we have a value from 0 to 1, right? And that gives us a magnitude of 1.414 maximum. And it's the maximum because the furthest distance you can travel in a cube is a perfect diagonal. So if we go over here, the value is going to be 1 instead. So this is the total distance of the diagonal of a cube or of a square, which should become even further with a cube because there's a third dimension. But the reality is that this is from 0 to 1, but we are actually using -1 to 1. And then we are just checking using that. So yeah. So in that case, multiplying by 0.5 kind of makes sense, but as we can see, when we multiply it by exactly 0.5, it's not so good. Because then we end up with a lot of rounding issues. But you can see here, like, the closer we get to divided by 2, the more fucked up it becomes. But I don't like this, like, subtracting weird things from it Doesn't really make a whole lot of sense to me. And we end up with shit like this here too, right? Like this is also not good. And that's not fixable with this slider. So I don't know if that's something different or... And you can see there is some glitter going on, which is also not very good. How did we fix this, man? Because there's an issue, right? Because in a way, it shouldn't really matter. Because I'm only ever checking against the voxel that we're currently inside. I'm not checking like intersection with its neighbor until we traverse into that neighbor. So it shouldn't really matter. But the reality is, like, if you're using some kind of like grid, then any entry in the grid isn't like 1 to 2 or 3 to 4. It's 2 to 2.99999 infinity, right? And that can make things a little weird sometimes. But it's solvable, like, pretty much always. But I just wonder if there's something similar happening here, but there should be a problem. Like, I just don't understand. Like, it's really close to functioning right now, right? But it's not close enough. So I have to divide it by a fucking weirdo value, otherwise we get that. I can try the div by 2, which is a precise static float. think... I don't feel like it makes sense. But we can try this. Again. Is that good? Nope. That didn't fix it. It reduced some stuff, but didn't really fix it. It's so weird. Like, I genuinely don't understand. Because I feel like the graininess I can understand. That makes sense. But the half shadow? That does not make any sense to me. Because we should be getting an intersection, and then the rest is just a triangle check. So why is it doing a triangle check? On like that side? And why is it like that? Like, why does it come from this corner? That's what's weird to me. And like the further I go, you can see it's only ever going from the corner. From here. And then if we go here, it goes from here. And these are two different voxels, right? So it only ever goes from the corner at the top. So when I'm over here, it doesn't work. So why does it work here? One clue is the color of the shadow. So what's happening is that it's because when we are at a certain point here, when we reach this point here, instead of stepping like up or in this direction, it steps in the direction of its neighbor. And then it intersects its neighbor. While when we're over here, it doesn't intersect itself. See, that's what's weird. It needs to intersect itself. And that's what's weird, because What if we try setting the max t value to be inclusive so that we don't get the 1? For that check. Nah, that didn't help. But yeah, I more or less understand what's happening. But it doesn't make sense. How do I fix this then? Like... I don't really want to change the voxel space to be minus 0.5 to 0.5, because that's gonna make math suck ass. Like, that's gonna be such dog shit. Or maybe it won't. Maybe that would be like okay. But no, I think it would suck. Because it would... I would need a lot of like... Nah, it would be okay, I think. Because what I have to do right now is... If I set the volume to be 0.5, for example, then I need to multiply that by 2 to get the correct value. Because it's actually 0.5 in each direction. While if I change it to be minus 0.5 to 0.5, then I simply have to subtract 0.5 from it. To center it? Yeah. See, what I think might be happening here is that I am doing we're doing a check in the triangle intersection called K epsilon. And I think that might be it. What if we set that one to a 2? Because I think what's happening there is that the value is becoming too granular, that when I then bring it back out, it's like weird. Because you only have so many decimals, but I don't know. It's far-fetched. Nah, I don't know. But here we can try changing this to 0.5, and then this is minus 0.5, this is 0.5, and then here we subtract 0.5 instead of 1. Like it could work. And this does not need to be times 2 anymore. But then we might have to change a whole bunch of shit. We'll see. Yeah, get voxel configuration. Everything here that says 1 needs to be changed to 0.5. Which means this can no longer be an int, needs to be a float 3. But it also might fuck up my alignment setup, because if the alignment is no longer... Because what I could do was, like, the alignment... I could kind of use that, because it was -1 to 1. I could use that to set an extreme, or set values. And that might not be possible anymore, but... There's some things here too. Like, all of these align voxel position, but I'm not actually using these right now. But that math has to be changed. We might be good to go. This doesn't look right. It should just be this. That actually, it does matter because max magnitude is based on that, so if the exit UV is wrong, then... We're still getting this here. I really dislike that. Because that feels like it's unrelated. Um... Ah. Wait, no. The alignment doesn't need to change. Nope. Oh, come on, man. Don't think that actually matters, though. We'll see. I don't think it does. Because right now I'm not doing any calculations with the neighbors. So it literally doesn't matter. The alignment shouldn't matter at all. Oh, apparently it did. But it has not solved the problem. The math, it does seem better. Because while we are still getting the glitch on those shadows, these shadows no longer have it. So I think that's a step in the right direction. At the very least. We're still getting this crap, which, quite frankly, this is like the same bug. I don't really get it. It kind of is, but it kind of isn't. I think. See, the purple it's really strange. To be honest. But the purple means that we have traversed a voxel. If the shadow is colored in the color of the voxel,
that means it's intersecting with itself, right? So the issue here is actually not that this is incorrectly intersecting with its neighbor, it's that the other half isn't intersecting with itself. Why? That's so strange. Or I don't know. You see, if we get it to the exact correct value here, what's happening is that this is the rounding errors, right? Here now, this is all fucked. I think that this value and this implementation here. I feel like this is like a non-issue in a way, because what's happening here is that the triangle intersection uses a dot product to figure out the ray direction, and if those values are like perfectly parallel, then it gets kind of weird, I think. And that's what's happening here. When the slope is perfectly parallel with the ray, that's when we get rounding errors. And that's where it starts going all checkerboard. But it only happens at like a very, very precise value. And I think what you need to do is you need to feather it so that for the first few values, it multiplies the strength of the shadow. That way, the first tick is just gonna be no shadow anyway. And so this should be returned, I think, kind of, in a way. Because here it's, if this is less than this, then we return. Hello, Robert. Something like that. So I don't really think this is something I care about right now. I think the bigger issue is the fact that the cube isn't intersecting itself where it should. Hey, help, what's happening? The compiler has been doing this a lot recently. It's like it's not compiling. I think it's just bugged somehow. But this, though, if yeah, okay. So 0.2, 0.5. Which one? Yeah. Cool AI synth waves so I don't get hit by copyright. It's like the only thing you can listen to anymore, or video game music. Everything else gets you hit. It's hard to stream on YouTube with any kind of music. It's like either that or just turn it off. Yeah. So this here is a slope, but it doesn't have any shadows. This one does. That's really strange. Okay, it's not that strange. It just happened to be that the angle. The Robert Renato tracks? Yeah, maybe. Maybe I could add that. So it's so strange. Yeah, there's like no difference between real tracks and AI tracks when it comes to these genres. It's like this and like drum and bass and whatnot. Like there are some actual drum and bass artists that make music that's like notable, but it's well few and far between. Otherwise, it's like the same song over and over again. Like it's easy to joke about like all prog rock being the same, but when it comes to like DMB and like this genre, it's really like almost everything is the same. Much more so than prog rock. feel like the ray has to be wrong. Like, something about the ray is just not right. But it, like, there's just nothing that really makes any sense here. All right, Robert, take care, dude. Have a good night. I don't know when you usually go to bed nowadays, but I don't know if it's morning for you. This is wrong now. Actually, messed it up a bit. Yeah, we can blame Kibbs. And that's perfectly reasonable, I think. Okay, that was wrong. So, okay. Does it work now? I love when you keep finding like bug after bug after bug, but none of them take. Like, it doesn't, like, there's like 40 things are wrong, but apparently it does nothing. Doesn't matter if it's wrong. Oh, come on, man. It's like, now we're getting this shit again. So it wasn't actually that fixing the thing fixes that. Why does it do this? Like, what? Because this is the second... I mean... It's like not really the second triangle either. That's really not what this is about. Doesn't have anything to do with the triangle. It's only about the angle somehow. But the angle is also irrelevant at the same time. So if we try to think, how could this be happening? The ray enters the voxel. We intersect properly, by the way, with the triangles. There's no problem with intersecting it and finding the actual surface. And then I take that position and so the way it works is that we enter the voxel, we have a ray, the ray has a ray direction, the ray's position is where it enters the voxel itself, that's its intersection point first, and then we
make a triangle intersection check against every triangle using the math for that. And if we intersect a ray that, or a triangle that's backwards, then that's a miss, so it doesn't count. So if it was to intersect two different triangles, which could be possible, I mean, it shouldn't be, but it was at some point. Because how can you intersect two triangles when a back face is cold, right? It doesn't really make sense. But it was possible at some point, somehow. Anyway. After we've checked all the triangles, we take the lowest t value, and t is the intersection point of the triangle that we have found that is an actual intersection. And then we figure out like the value t is from where we entered the voxel to where the triangle is. It's the distance in normalized magnitude. Well, not even normalized magnitude, but it's like, because I was doing -1 to 1, it was a magnitude of 0 to whatever the magnitude of 2 diagonally, like maximum. Like it was a value between those two things. And lost my train of thought. So t is the distance traveled within that space. So the way it works is that, let's say I enter the voxel at like 14 in the x. Then when we enter the voxel, I then change the 14 to, it used to be -1, and then it was like checking a space from -1 to 1, which was then the end of the voxel. But because that was -1 to 1, that was a total value of 2, which meant that the t would become too large to then be transferred back into world space. And now it's -0.5 to plus 0.5. So now it's a value of 1 total. So that should be fine there. So when we find the intersection of the triangle, I then send the t value back, and then I take the position of the ray where it entered the voxel. I then take the ray direction, and I multiply the ray direction by the t that we returned from intersecting the triangle. That should, and it isn't wrong, it should increment the ray to the point of intersection, right? And then from that point, I then calculate the ray direction from that point to the sun. And the sun is like up in the corner. And then I'd make a check against, like, we're inside of the voxel. So I then check against itself again. So it then like raycasts into itself. And then that should find the triangle again. But at 0. But it might not. And I guess that's partially the problem, but it's like not really as well. That's what's so weird about it. Because to me, that's the logical problem, that I'm actually like, there's too much, the floating point variance is too big, so that we end up with just randomly not properly intersecting. But then here it is intersecting with itself. At least I think so. Yeah, it is it's intersecting with itself there. But then here it doesn't. So how can this value be that wrong on this side, just based on the sun's position? And furthermore, it's even weirder because the floating point error isn't actually based on the sun position. It's based on the camera position, which means that it's an issue with the original, with the actual intersection value somehow. But if we go back in here, see, we're now even setting new float 3s for everything here. And you might note here, we're setting a UV here. And that's position minus floored position. And that means we can never have a value that's actually 0.5 or 1. It's always going to be 0 to 0.9999 infinity or 0.49999. And I don't know if that's an issue here.
Because here you have that problem there, right? What if we move this over? The other side of there. Is it the same? No, it's not. Here it actually behaves differently. As you can see, there's just something that's just weird. I mean, it actually makes some sense here, to be honest. Like this is a bit strange, but not really, because this purple red color, this is actually a shadow, but it has traversed a voxel. And it's intersecting with something else. So it's actually like correct. And that does kind of tell me that there is a bit of an issue here. Because what this kind of means is that a voxel can range from minus 0.5 to plus 0.5, correct? But the ray can only range from minus 0.5 to plus 0.499. And that means that when we enter from the positive side, we're actually like always starting here, which shouldn't work. What's strange about it is that if this was truly the issue, no. Yeah, this is the issue. It needs to have... It shouldn't. No, it shouldn't matter in this scenario. Because... if we go up a little bit, here I'm doing the same thing, but here I have to do this. I have to check which mask is true, and then I have to check what the ray step is, meaning are we stepping to the left or to the right? And then if it's true, if the mask is true, meaning like we entered from the right or to the left, I have to manually set the value to be the full value. Because otherwise it's impossible to set that value. But I don't think it's relevant. It actually might be, kind of. Because what's happening is that if we enter a voxel from the right, the top, or the back, those values are whole values. And what that means is that the very edge of that side is actually the next voxel. But because we are in like local voxel space, going to 1 doesn't actually like read the next voxel because they share an edge, right? Like the previous voxel has its edge on the exact same value that the next voxel has its beginning. And it's kind of the same thing with like textures and stuff. It becomes a little weird. That's what I was talking about before, when the final, like the end of the texture is actually the start of the next texture, and therefore you can't actually use like 0 to 1 as a proper value for textures at times. So
So in this scenario, I don't think it should matter, because the issue right now is intersecting a diagonal, right? And the diagonal is in the middle of the voxel, so it should never have this issue that we're currently running into. So this shouldn't be relevant, but it should still be an issue, because if it was a perfect square or a perfect cube, then its side would be at 1. And I would only be able to be at 0.999 at the start of this UV here for the ray, for the light ray, by doing it the way I'm doing right now. So I have an idea, which I kind of doubt it's actually gonna work, but it kind of might work, because it might be this conversion back and because what I'm doing right now is kind of I'm kind of like converting it into world space, like from local space to world space and then back to local space. So what we're gonna try doing here is, instead of actually calculating the ray with the entry position and all of that, we're just going to keep using, we're gonna use the entry UV, and we're gonna use that instead here, and we're only gonna calculate the rest if we don't intersect. So this should be entry UV plus ray direction plus T-min. But that should be correct here. Because what I'm worried about is that this like teeny tiny thing missing at the end in this conversion might cause it to act like there's like a stretch, kind of like a minor stretch. I don't really think I'm doing that either. And what I mean with that is, like, if the values that we're really relying on are from, or that we want are from 0 to 1, but we can actually only go from 0 to 0.9999999, then in the conversion, it might kind of end up in a way where everything is kind of stretched out towards the 1, tweaking all the values a little bit upwards, because it's like it's being it's being stretched. I have had issues like that with the other project. But I kind of don't think that that's happening here, but whatever. But it doesn't work. What we can do is something like this, maybe. then, because I need to calculate the ray direction. So we need that. And then we're just gonna use this light ray position. We can try it. It feels different. Well, it's different, but it's not fucking good. Oh, fuck. Actually, is this a bug? That could have been a bug? Not sure how the compiler handles that. It should be fine. Yeah, no, that didn't make a difference. This is even worse. Yeah, but none of these things should matter. This is all whatever. At least for the initial check. That shouldn't matter. I don't know what I just changed. Let's just try. Don't know. I don't know. This could be a bug. A bug. That can have been fucking me for a while, by the way. This is actually kind of correct. It's just... It's now ruined because... This is not right. So then there's some floating point error going on. We'll see how it handles this first. Because now we should have the cast shadows as well. Because if you look here, this is actually incorrect. This should not be showing up here right now. But you can see the second this reaches 0, that's when this pops up. And this is actually correct. If this doesn't show all this garbage, then this is correct. But I don't understand why it shows all the garbage. I don't understand why it does that either. Fuck me, dude. Ah. Why is it like this? I don't understand. Because like, to me, this should be correct. Let's check the K epsilon again. The last time I tried messing with the epsilon, I didn't feel like it made any difference in this case. Right? And it like... It's kind of relevant, maybe? But like, not really. At the same time. What is it determining? It's like it doesn't do anything with the ray. This is like a world position. Like what? I figured that would have to do with the angle of the ray to its destination, which is up there. Well, in that case, yeah, okay. So that ray isn't based on here's the reality. If we have shadows casting down here, then there's shadows casting on the slope. There can't be shadows down here if the slopes aren't in shadow. So this here is kind of odd, to be honest. And this is actually on the voxel down here. It's casting up and somehow intersecting with this before we are actually intersecting. I mean, not really. There. Because the K epsilon determines how steep we can go. Oh, goddamn. Did I make a change in here that would fuck this up? I remember doing something. That. But I doubt it. Nope. Still fucked. Ay. The max magnitude might be fucked up. I don't feel like it should matter. Might though. This can cull it? But I don't want to do that. This fixes it. I don't understand. Because I feel like this should be a problem. Right? And it is. And I feel like this is the true issue, or was. So like, not really? All we need is a value higher than 0? Yeah, because the t I'm returning is supposed to be zero. Really. Or near 0. It's probably time to stop. I'm getting tired and this is so weird. That works there though. But what if we move the sun over there? Does that still work here? Yeah, but this is the issue with multiplying. Like, any solution that really relies on multiplying like this is kind of like error prone. And you end up with little blinking dots all over the place and it just sucks. So I feel like that's the wrong solution. Is it so weird and laggy here? strange. Ay, ay, ay. Yeah. This is classic. Classic shader programming. Classic. It runs really badly, by the way. It's partially because what is it with the blacks? What happens? What is that? I don't feel like that should be possible. But that might... Is it a step limit thing? That why it's black here? Think so. For whatever reason, we have unlimited steps there. Ah. Yeah, that happens when the light and the pixel are exactly Why? Well, that'll be that for tonight. Do you have a target FPS and view distance? Not really. There are too many things involved. But I would like to be able to rival Minecraft at least. But I think that's a tall order. Because I'm doing right now I've implemented like a marching cubes kind of deal. And really, like, if you're doing anything that isn't just pure cubes, that comes at a significant FPS loss. And because of that, expecting like massive draw distances, probably not realistic. But there are still optimizations to be made. So I don't know. Because that's the reality. Like, let's take a look at this real quick. Let's set this to 0.99999. And then we build this thing. And then pop open Insight Graphics. I might have to just start it twice for whatever reason. Yeah. Was it just because I didn't? It's admin. Then we hit F11. Collecting data. Oh. Dispatch is 5 MS now? The fuck? Here it says live registers 241. Registers 249. Number of warps 8. So we have managed to reduce that a bit. PCIe throughput is 19. I don't know what SM throughput really means. Unallocated warps. But yeah, the fact that this is 5.8 ms now sounds really, really bad. But it makes sense to some degree. But I need to reduce the amount of globals that exist within my my loop. I think that's key, because when it comes to registries, from what I understand, you want to be around like 120 maybe. And having registry overload, I don't know how this shit works. I'm not gonna pretend like I do, but it'll basically stall it and it'll choke up, and then it'll run like shit. Because this one here, this one was like 3.6 last time I did this. And then I got some advice to because what you can do is you can create buffers, CPU buffers that contain data, right? And there are several different variants of buffers. So you can have buffers that have like shared memory between the CPU and the GPU. And that's kind of used as a writing buffer for like writing new voxels into memory. But that's slow. So if you use that type of buffer for all of your voxels, it's going to run really poorly because the PCIe throughput is going to go up and your it's just going to get clogged up. And it's just slower in general. So what I did was I changed that to a static buffer because that's what it's supposed to be. Well, not a static one, but a GPU only buffer. So we upload ones to it and then we can't change it. But the GPU can change it, but the CPU can't. And that reduced this, and it reduced the dispatch execution time from 3.6 to 0.9 at the time. And now it's up to 5.8 after adding shadows. And
And it doesn't make any sense either, because, to be honest, the amount of registers went down, but I've increased the amount of loops we're doing by like a factor of 2. I kind of... I don't know. I don't know how this really works either. How does it measure this exactly? Warp latencies. This is so complicated. And like learning this shit, reading on Nvidia's homepage, or in just reading the DirectX 12 docs. Yeah. The problem with the Nvidia pages is that it's just a bunch of articles. So it's like you can't start and like go through it in a way that feels like it makes sense, or go to like the chapter on this or that or that. It's just like a bunch of articles, which is super annoying to actually read through, digest, find what you're actually looking for. Just like a bunch of blogs. I don't know if it's CUDA. I'm not so sure. No. I don't know. Whatever. I don't even know where it was. Like, I don't know what it was, what I was even looking at. I don't remember what I was Googling. But I was... Maybe I was just trying to find out how, like... Insight, how to use... Because that's the thing, right? Like, you basically need to know what everything means here. Like, what is SM throughput? What is unallocated warps? What does samples mean? 100% samples? Average warp latency, is that good? Is that bad? Instruction mix? FP32 math? FMA? Logic operation? Data movement? FP32 comparison? Integer comparison? Control flow? Branch? I don't know what FP32 math means. Floating point 32. So I guess that's just regular mathematics. Multiplication, subtraction, plus addition. And the question is that bad? Int to float. Yeah, conversions aren't good. The GPU is a lot more... Here, top stall. ALU, integer comparison. Wait. CPU control flow, branch. Data movement logic operation. Warp was stalled waiting on a fixed latency execution dependency. Warp was selected by the micro scheduler and issued an instruction. Warp was stalled waiting for a scoreboard dependency on an L1 TEX, local global surface TEX operation. What? But it says integer comparison. Long scoreboard. Yeah. GR engine active. L1 text hit rate. But yeah, there's a lot of stuff that can be changed here. There's a lot of techniques. For example, light rays need to travel to the edge of the world in order to determine whether it's going to cast a shadow or not. And for that, what you can do is, for example, you can do a height test on the world where you're currently at, and you can generate a height map. That way, when you cast the ray, depending on the size of each block of the height map, once you go past the height value on the height map, you can basically skip for as long as you like, until you exit that block, kind of. And that can be like the entire rest of the map. It depends on the angle of your ray and the width of the areas that you're generating. But this also has a weakness where if there's like something up top, then it doesn't work. So it doesn't work in certain edge cases. It's still pretty good technique though, I think. But and then there are other issues like I'm using an acceleration structure called a brick map right now, which is basically just there's so many different names for it. It's just basic, you know, splitting the world into sectors, and then that's that, you know. We just do checks if there's something in there. And it's the same thing, it's just this with rays. So If there's empty space, then I just skip it. More or less, like in steps of 8 and in steps of 64. But if they're not empty, then I have to take one step at a time, which means that if you're standing like somewhere here and you're looking along edge here, that should have much worse performance than if you go up here. Now, in this case, there's no difference, which makes me wonder if it's even working in the first place. Because this should run a lot worse. Because this should mean a lot more steps is being done. So, and that's something that can also be kind of alleviated if you can create some kind of system where you do straight line elimination of the traversal. Then you can speed that up a lot, but then that only works in a straight line. It won't work in a diagonal. So then if you do it that way, you're gonna end up with like uneven performance depending on just which direction you're looking, and that might be worse than it just running poorly evenly. And then every single voxel takes up memory, even the empty ones, even the invisible ones underneath here. That needs to be culled, and that might also increase performance, potentially. If nothing else, it might allow me to have more higher draw distance. But we'll see. Because I need to have light, right? Like the light rays need to exist. And then we also need game logic. And I'm already down to 100 FPS. Hello, Mr. Beanless. This is Raymarching engine I'm working on. Was just running some profiling tools on. But we're gonna stop there because I'm tired and it's almost 2 a.m. We'll continue soon. Tomorrow, maybe. I do have things I need to do otherwise as well, but we should continue tomorrow. Hopefully we can figure out these shadows so I can go back to getting the voxels to render properly, because they're not finished. But the shadows are fucked. I need to figure that out. Until next time, thanks for hanging. Have a good night. Bye-bye.